Hi, good afternoon, everybody, and welcome back. The next topic of discussion, we are going to have the next presentation on utility, metering, and acquisition of AMR data using the different communication protocols. And ladies and gentlemen, we have our next speaker, Mr. Vasu, Managing Director, PHYTEC Embedded Private Limited. Mr. Vasu has 15 years of experience in embedded technologies, mainly on ARM and Linux. He has worked at major MNCs like LG, Wipro, Mike Electronics, and currently heading PHYTEC India. The industry vertical he has engaged are industrial automation, mobility and energy, medical, healthcare, and retail market. Apart from his technical work, he is an active coach and guide for embedded developers and actively spend his time to train the developers on embedded Linux, IoT, Android system development. And he is the mastermind behind the open source hardware platform. Mr. Vasu is a mentor who always helped the startups to build their products and position them in the market. So ladies and gentlemen, let's welcome Mr. Vasu. Hi, sir.
Hi.
All set?
Yes.
So you're not audible. So if you can just check your audio.
Am I audible now?
Yes, sir. Yeah, perfect.
So, good afternoon all, and let me just share the screen.
So now I leave the platform to you, sir. Over. Yeah, thank you.
Good afternoon all. Thank you, the team, to enable us for this session. So let's discuss on the upcoming major changes in the market and then existing technologies for utility metering. So maybe like this is more oriented towards the energy meter, but like mostly I think in upcoming era, we would connect gas, water and energy meter together. So that's why instead of energy meter, we put as utility meter. Just for a quick agenda. So quickly we will discuss on the PHYTEC introduction and then overall smart meter system architecture, smart metering subsystems like your majorly the MCU and the COM module and the technologies, and finally the gateway and edge computing devices. So further the cloud side, I am limiting myself. So for PHYTEC, so it's a 35 years old German company. So we started in India 12 years back. And then today we cater system on modules with primarily TI and NXP. And then we have other semiconductor partners like ST Microelectronics and Microchip and Renesas. So we help our partners to build their own single boot computers. And we also have some standard single boot computers with us. So we have a few Internet of Things modules, mainly on the wireless modules. PHYTEC also have a industrial imaging vertical where we do industrial camera development, module developments. And then finally, we also help all our customers to build their industrial grade Linux and Android DSP for all these hardwares. So PHYTEC in India, we extend our development team to provide multiple embedded development services. So which starts from your hardware design services and then the software development. We also provide end-to-end product development services till the manufacturing. So we also take up OEM, ODM manufacturing. So finally, we also support our partners with competency building. So we set up offshore development centers and innovation so these are the kind of system on modules. So with all major ARM cores, mainly we are specialist on ARM processors basically. So you can see we have SoC lines from NXP, TI, and then ST Microelectronics. So we also had one of the chip from Rockchip, mainly for the industrial tablet. So these are services where we also do the hardware design, software development, and then finally to the manufacturing. So we have a high quality manufacturing setup in Germany. So we design, develop, and manufacture system on modules in-house. And in India, we have EMS partners to support the Indian ecosystem. We also support our customers to build their product to our global standards and certify them for the global market. So let's come to the second point of the discussion. I think since morning, since yesterday, we have been already going through this, the complete smart metering system, big system, but again, a small overview. So when you want to see the big picture of smart metering systems, so you have the first is your the consumer, so where now the home basically, so you have not only the energy meter, but mostly this will be, you have a lot of connected devices in your home, and then obviously, so there will be a phase where we already started that, like the energy meter also interact with other devices and you set the rules. So that's where your home area network comes with all the smart devices at your home. Then your smart meter, which not only powers up, as on today it powers up, but like later on you would see that like these would be also closely interacting with your other devices and see how it can efficiently manage those devices also from a personal perspective. Then you have a communication system. So in your communication system, where the smart meters are connected to HES hidden systems. When you are depending on the technologies basically. So what communication technologies you can see either it is directly connected to the through what wireless network, cellular networks directly to the HES, or it can go through the gateways where you can have your mesh networks and then like connected to the HES. So the gateway is connected to your HES. So once the HES, your actual data management system comes, where your all your data is stored for advanced metering, and then like infrastructure, and finally the data which is securely stored, and then like now a lot of technologies on the cloud for the load balancing, security and all. Then finally you distribute it to the retail companies who want to do like say billing, and then also probably not only the companies, though these companies would directly also enable the users through their mobile app and so to access the data. So this is overall a big picture. So now coming to the smart meters. So as you know, the PHYTEC is mainly a digital electronics, high-speed digital electronics manufacturing company, but like we also help our customers to design and develop microcontroller based products, and one of the The key product we have supported with respect to the energy is the energy meter. So this is a reference design from Aayera. So we and NXP. So we, as we told, like we are a design house partners for NXP, TI, and Renaissance, and then like we also have some good experience with Synergy. So we help our customers to design. So now coming to the smart meter, which acts as your endpoint for all of the smart energy infrastructure. So the major components, if you see, the first main component is your microcontroller. And then nowadays, the SoC comes with all your needed peripherals for energy meter. So it's now more easy. So you need not to really interface an external ADC for your metallurgy for the metering purpose, right? So, and then like you have all the security stuff. So today, most of the microcontrollers are in Cortex M3, M4, and M7. But like soon you would also get secure enabled microcontrollers like Cortex M33 and Cortex M55. So PHYTEC being a pioneer in microcontrollers and microprocessors, we closely work with semiconductor companies and support them. So the second component of the meter, now you can see that like to make it more the energy meter, smart energy meter, more multi communication enabled. So you can see the NIC card. So this is a detachable NIC card which sits on top of your smart energy meter. So which gives you the flexibility for heterogeneous kind of network on the field, right? So in this case, the image depicts your cellular module. So, but like you can, this is a standard NIC interface, like, so you have a standard UART interface and then the power to the NIC card, and then some handshaking signals which comes from your energy meter board to your NIC card basically. Now coming to the communication technologies, I would not debate or argue which one is good. From our perspective, what we see is all technologies coexist. So it depends. Since morning, I think a lot of people have been discussing. So to recap the technologies, the first thing is basically, so on a logical categorization, so you can see the first category could be the wireless star network. So where in which you have base station and all the nodes directly connected to the base station, enabling the direct connectivity to the cloud, to your HES system, right? So where the first thing comes your 4G, then the NB-IoT, the LoRa public network, I would say. Today in India, Tata and Sandra are the major LoRa public network provider. And then for the NB-IoT now, you know, the Geo would be the major player. And finally, the 5G would be the game changer. Because a lot of things you see that like today the communication, cellular communication have some limitation to coexist with the IoT applications and all, but like those will be a little bit more merged. So the NB-IoT has taken over the IoT part, but like now it would be more the 5G. We should see that like it brings a lot of advantages and the features which really fits it. So the next one is the RF mesh. So as you know, when you want to go with any of these network, you have your service provider in the backend, and then for each device you have some cost running on the lifetime, because it's a licensed band. These network the LoRa is like, even though it's not licensed, but like they have a huge infrastructure they have to maintain. But essentially the cellular have a license where in which the RF mesh brings you in a bit of advantage, where not every device need to be connected directly to the cloud, but you can use the concentrator or the gateway, you can see, which connects to the multiple devices, and then like it sends the data to your HGS system, right? So the Zigbee was the starting point when it started almost 2 decades back, basically. Yeah. So and then now we have a few more technologies, the protocols which has been already started getting into the market. So few of them, so few installations happen using WirePass and Vasu right now. Japan is leading the player where the Vasu has been adapted and then already in use. So coming to the Wi-Fi, so the Wi-Fi 6, which is the next gen, again would be a kind of a upcoming game changer, where like the major disadvantage of Wi-Fi was the power, but like those things would also would be addressed in Wi-Fi 6. So here when you talk about RF mesh, you have one is 2.4 gigahertz basically, which is a short range, and then you have a sub-gig radios, which are long range wireless, low power long range wireless basically. So the third, as you know, like the PLC, which would be as on today, there is a challenge in India because of the harsh environment and climate conditions. So, but like there have been a few deployments which have been happening through power line communications. So as we feel basically, so all the technologies coexist. It's not that like this is the only technology which is best, and the mass deployment and future smart meters would be using only this. And then as you saw that like the NIC card is a modular one, which can be for the same meter, you can attach any of these technology NIC card. So we help our partners to develop. So we have cellular partners like Qualcomm, Quictel, and Neoway and Sierra Wireless, and then we have TINXP and Scilab as SoC partners for RF mesh microcontrollers, and then so we also do support partners to develop their integrate their PLC modules. So now the last but the important topic which we want to more focus is your edge gateway and the edge computing device. So let me quickly give you the gateway classes. So traditionally we used to always say the data concentrator, and then you also have for monitoring and then accessing the remote devices, RTUs basically. So today more IoT way of calling them is a gateway. So if you want to classify a gateway, so gateway can be classified into Gen 1, which could be a very low power gateway based on your microcontrollers, say ARM Cortex M3, M4, or M7. The advantage is they are very low cost and low power, but at the same time you have a limited memory and limited features. But when you just want to have few hundreds of devices, and then you have to receive the data packet and convert it to another wireless protocol. So very much possible by these microcontrollers. The second one is generation 2 gateways or DCUs, where you have the microprocessors basically, which runs embedded Linux, and the cores, if you say ARM Cortex A5, A7, A8, and A9 kind of application processors which runs embedded Linux. The major advantage of these gateways, Gen 2 gateways or DCUs, is basically, so as Linux is running, it is rich of software stacks, so you can have multiple network stacks, security, local database, and the best thing is it have good memory, which can always act as a proxy for your node devices, and also it can do a lot of device management on behalf of your HES or HES basically. Finally, you have the gateways or DCUs, which could be a next gen. As you know, whatever the technology grows on the cloud side, always you want to have on-premise intelligence, which whatever level it is possible. So this is right now possible because of the latest 64-bit MPUs, which also holds VPUs and NPUs, neural network co-processors basically, so which have hardware accelerated engines for your AI ML. So what happens, the trained models are fed to these edge computing devices, and then it is self-sufficient to take some decisions and then control the devices on-premise or to a limited geographical region basically, so that whenever it have a connectivity to the cloud, so still it push the all new data and try to learn the new behavior from the cloud servers. So today the HES and MDM, but tomorrow you can see there would be a layer of analytics, which already Oracle, you have seen that a lot of analytics has been embedded into these. Right? So this would be a kind of on-premise small scale servers for the on-field devices basically. So these are a kind of some modules which are available for the DCUs. IMX8M Plus from NXP, which have embedded Linux and AIML neural co-processor NPU, and then it enables you with all the Linux AI stacks like your KF and TensorFlow Lite and other latest Python-based stacks for the edge computing. So we have been, our team has taken a small initiative to build open source single boot computers. So I believe today in India, we have a lot of small projects or POCs has been done on an open source platform, learning platforms like Raspberry Pi or so. So taking an initiative, so we have done an industrial grade open source single boot computer, where the designs of this single boot computer is available, and it is powered with PHYTEC song, which brings you the industrial reliability and ruggedness. So that's why it is called rugged board. So you can see it have a lot of industrial interfaces which can be used as a DCU or RTU with a very low memory footprint. So we have classes. We have higher end memory and higher end processors. This is a small initiative by our team. I would be happy to take the questions, if any, by the participants.
Thank you, sir. It was really wonderful having you. So we have questions for you, but we are going to send you an email as we are running short of time. We have begin the next session. Thank you so much.
Thank you.